So your test, again, is tomorrow. We're going to be going over the study guide. Remember, everything that we go over is very, very similar to what you'll be tested on. If you can understand your study guide, you will be perfectly fine for tomorrow's test. You won't need the whole class period for tomorrow's test either, so be prepared for only a small amount of time. Probably like 35 minutes, maybe 40 at the most, okay? You can do it. It's not a long test. It's not a difficult test. So for here, how to tell whether we are talking about a missing value from a proportional table. So we're saying that this table is proportional. That means that every y value divided by its x value is going to be equal to each other. So what do we do to find a missing value? The first thing that you can do is you can create a proportion. So you're first going to pick a point. It does not matter which point you pick. I could pick the first point, I could pick the second point, or I could pick the last point. It doesn't matter which one. You just got to pick one of them. I'm going to go ahead and pick 4 and 20. So now I'm going to set it up a proportion. So I'm going to set the 4 and the 20 up as a ratio. I'm going to go ahead and do it as y over the x, because I always like to do y over x. But you could do 4 over 20, it doesn't matter. But based off of the way that I set up my 20 over 4, how do I have to set this one up? What would have to go on top and what would have to go on the bottom? I set it up as 20 over 4. How do I have to set this one up? Victoria. X over 6, right? This is the value that's missing. That's our question mark. So we have to put it over 6. Okay, if I did 4 over 20, I could do 6 over x. It doesn't matter as long as you set them up where they align. Okay, once you have this set up, then we could do our cross product to solve. So we can multiply 4 times the x, which gives us 4x. We can multiply 20 times the 6, and that gives us 120. And then we can go ahead and divide to solve. We would divide both sides by 4, and we would get that x is going to be equal to 30. Based off of that, I want you guys to do problem 2 on your own. Do problem 2 on your own. Okay, let's go over it. It doesn't matter which point you pick. You just pick one of the points and set up the proportion. So we're going to pick a point. I'm just going to go ahead and pick this point, 4 and 31.00. So that's 4.0 and 31.00. Again, like I was saying, it doesn't matter how you set it up. I could do 4 over 31 or I could do 31 over 4. The only reason why I'm saying try to get used to doing 31 over 4 is because you need to make sure you remember it's always y over x. It's always going to be y over x. So I'm doing 31 over 4. I want to set it equal to x over 6. And then I do my cross product. So we multiply 4 times x to get 4x. We multiply 31 times 6 to get 186. And then we can divide. We would divide both sides by 4. And we'll get that x is going to be equal to $46.50. Any questions so far? Okay. All right, number 3. It was this a proportional relationship. So we're looking at the graph. We want to know, is it proportional or non-proportional, and how do we know? So first thing we need to indicate, is this a proportional graph? Yes or no? Yes, it is proportional. So I'm going to write down, this is proportional. Who can raise their hand and tell me one characteristic that lets me know that it's a proportional relationship? What's one thing we look for proportionality, Liz? It goes through the origin, okay? So it goes through the origin, which is located at the center, or the corner point, right, where 0, 0 is located. So yes, it went through the origin. What's the other characteristic that we're looking for, Renee? It's a straight line, right? This is a straight line. So we are looking for a linear relationship or a straight line. Okay? If it goes through the origin and it's a straight line, then it is a proportional relationship. All right, problem number 4. We want to know which one of the following is considered to be the lowest unit price, so the better deal. How do we find out the unit price? What goes on top, what goes on the bottom? Amina? Very good. Cost goes on top, quantity goes on the bottom. So for here, for this one, for 35 ounces, and it's $5.79, we are going to take $5.79 and we are going to divide it by 35. Okay? When I do that, I'm going to get 0.1654, and it's just going to keep going on. I got to round it. I got to round it to the nearest penny spot. Remember, my penny spot is located at the 6. So I'm going to look at the number behind it to tell me how to round. So am I going to keep this at 16 cents or round it to 17 cents? Round it to 17. Good. So we're going to round it to 17 cents. Now we're going to do the same thing for the 16-ounce jar. The 16-ounce jar, it was $2.49. We're going to divide it by 16. Once we do that, that's going to come out to 0.1556, and it's just going to go on. Again, the 0.15 is where my money is located. Anything after it is my rounding value. So is this telling me to keep it or round it? To round it. So this is going to become 16 cents. So which one is the lower price? 35 ounces or 16 ounces? 16 ounces. 16 ounces is the lower price. Okay, let's do the same thing now for the Welch's fruit snacks. I want you guys to find the unit price for each of them and then identify which one is going to be the lower unit price. All right, let's go over it. For this first one, we're going to do $2.09, and we're going to divide it by 10. When we do that, we're going to get 0.209. What is that going to become? Huh? 21 cents, right? 21 cents. Okay, then for the next one, we've got $4.89. We're going to divide it by 22. That's going to come out to 0.222272, and it just goes. So what are we going to write that as? 22 cents, right? 22 cents. So the 10 count winds up being our lower price. All right, for problems 5 and 6, we are trying to find the average speed in miles per hour. It's telling us how to set this up. It's saying miles per hour. That means miles is going to go on top, fraction bar, hours is going to go on the bottom. So our miles is 15 3/4 miles. Our hours is 1 1/4 hour, or sorry, 1/4 of an hour, 1/4. So we have 15 3/4 over 1/4. Now you just divide. You are dividing by 1/4, and that's going to come out to 62.4 miles per hour. Go ahead and do number 6. So fix that. That should be 63, not 62.4. I apologize. Okay, if we did number 6, who can tell me? Who can tell me what they got? Daniel? 61, correct. Okay, so if we're taking our 30 and 1/2, and we're dividing it by 1/2. And that's going to come out to 61. Because again, all you're going to do is divide both the numerator and the denominator by 1/2. So you get 61 miles per hour. Okay, go ahead and flip it on over to the back. Okay, on the back, you're going to be doing the same thing again, but instead of miles per hour, we're now wanting to know how many calories per serving. So it's the same thing for problem 7 and 8. If we're setting this up, it's going to be 24 calories, or 24,000 calories on the top, and 12 servings on the bottom. So we're doing 2,400 divided by 12, and that's going to come out to what? We do 2,400 divided by 12, what are we going to get? Huh? 200. So you get 200 calories per serving. Okay, same thing for problem number 8. Problem number 8, a smoothie contains 1,500 calories and it serves 5 people. So we want to know calories per serving. So we have the number of calories and we have the number of servings. Okay, 5 people, that's the same thing as 5 servings. So we're going to do 1,500 and we're going to divide it by 5. What is that going to become? 300 calories. So we get 300 calories per serving. Okay, for problem number 9, I want you guys to identify whether the graphs are proportional or not proportional. Are they proportional graphs or non-proportional graphs? All right, the hiking distance, is that proportional or non-proportional? Proportional, right? It's a straight line. It goes through the origin. Right? Check mark for it's being straight. Check mark for it going through the origin. What about the fir tree growth? Proportional or non-proportional? Why is it non-proportional? It's not going through the origin. The issue in line is right here. That is not through the origin. Non-proportional. So it's still straight, but it's not going through the origin. The origin is what it's the issue. We're going to cross that off. It does not satisfy our origin. What about the third graph? Why is it non-proportional? It's not a straight line, right? Non-proportional because it's not straight line. Does anybody remember what we said we called straight lines? What was the word? Amina? Linear. Very good. Pride points for you today. Thank you. Okay? So it's not straight. It's not linear. All right, let's take a look at problem 10. For problem 10, I want you guys to tell me which price of the apples is the better deal and why. You got 3 pounds of apples for $5, 7 pounds of apples for $11. Which one of those is the better price? How do you know? Actually, and I want you to tell me how much better of a price is it? Let's go a little bit further. Find out which one is the better deal and by how much. Is it better by 2 pennies? Is it better by 30 cents? Like, how much better of a deal is it? Okay, which one is going to be the better deal? 3 pounds of apples for $5 or 7 pounds of apples for $11? Daniel? The 7 pounds. Okay, let's talk about why. So if we look at the 3 pounds of apples for $5, we're going to take the $5, we're going to divide it by 3. That's going to come out to 1.67, right? $1, and it was 6 repeated, and I'll even show that. Just kept going, 6, 6, 6, it kept going. So that's going to estimate to $1.67. Okay, then we have the $11 for 7 pounds of apples. When we work that out, that comes out to like 1.57, I think it was 1.571, right? And it just kept going. That's going to estimate to $1.57. So now my question to you, obviously I know $11 for 7 apples is better. By how much? By 10 cents. Okay, so I even want to write that down. I want to make sure I'm making note that the $11 for 7 pounds is a better deal by 10 cents per pound. 10 cents per pound better. All right, let's take a look at problem number 11. For problem number 11, Jay and Nathan are both racing. So this graph is identifying Jay's speed, how many seconds he's running for, how many meters he is able to cover in that matter of seconds. Then we've got Nathan's racing speed is displayed by this table. So I want to know, what is Jay's racing speed, what is Nathan's racing speed, and then which one of them is faster. Which one of them is faster? So let's start with Jay's racing speed. So the first thing that we need to do is that we're going to just pick a point, and then we're going to set it up as y over x. We're going to pick a point on the graph and set it up as y over x. So the only point that I can see that's a nice perfect point is located right here. Now, if I follow this point down, all the way down, it takes me to the 4. And if I follow that point all the way to the side, it takes me to the 24. So that gives me my ordered pair. Which one of these values is my x? The 24 or the 4? The 4, right? These are my x values. The vertical axis is my y values. Pause. So when we're setting this up, we're going to set it up as 24 over 4, and that's going to come out to 6. Now remember, this represents 6 meters per second. So it's 6 meters per second. Okay, so now we're going to do the same thing for Nathan's race. Nathan's race, we're just going to pick a point. It doesn't matter which point you pick, as long as you're not picking 0, 0. Remember, we always say we ignore the 0, 0. We ignore when x is equal to 0. So we pick any other point, doesn't matter. I could pick 422. So if I pick the point 422, again, I have to set it up as y over x. Which one of these values is my y? The meters, right? The 22 meters. Seconds is my x. Remember, time is always going to be an x value. So we're going to set this up as y over x, which means it's going to be 22 over 4. That's going to come out to 5.5 meters per second. Okay, so we've got Jay's racing time. We've got Nathan's racing time. Who's faster? Jay's faster, right? Jay's faster because he's got traveling by a higher value, right? Speed is about higher numbers. It's not the same thing as better price. Better price, you want lower. If you want faster, you want a high number for fast. So Jay's racing speed is faster. How much faster is he? 0.5 meters per second, right? Jay is faster by 0.5 meters per second. Okay, so we found how fast Jay was running, we found how fast Nathan was running, and then we were able to compare who was faster. All right, let's go on to the next page. Problem 12. We want to know whether Sophia and Liam's swimming is proportional. So Sophia swims 12 laps in 4 hours. Liam was able to swim 18 laps in 6 hours. Are these proportional rates? So you're just going to set them up and solve. You've got 12 over 4. What's 12 over 4 going to equal? 3. Then we're going to do the same thing for Liam. We've got 18 over 6. What's 18 over 6? 3. So are they proportional? Yeah, it is proportional. Because they have the same unit rate. Oop. They have the same identical unit rate that makes them proportional. All right, number 13, again, it's another one of those, which one is the better buy? Which one has got the lower unit rate? So go ahead and do number 13. 12-ounce bottle of juice for $4.50. 20-ounce bottle of juice for $7.20. Which one's the better deal? All right. If we do the 12-ounce bottle, $4.50 over 12 ounces, who can raise their hand and tell me what is the unit price going to be? We do $4.50 over 12. What was the unit price? What did it come out to? Go ahead, Alma. 38 cents, right? If we were to divide, it comes out to 0.375. You would estimate it, and it comes out to 38 cents. Right? If you round it properly, it's 38 cents. Okay? 20-ounce bottle, we've got $7.20 for a 20-ounce bottle. So when we divide, what is that unit price going to be? Daniel? 36 cents. Comes out to exactly 36 cents. Okay, 36 cents. So which one's the better buy? The 20 ounces, right? So 20-ounce bottle is the better deal. How much cheaper is it? 2 cents, right? By 2 cents per ounce. All right, finding constant of proportionality. Remember, when we talk about constant of proportionality, we are talking about the value for k, where we set it up as the y value over the x value. Okay, constant of proportionality is taking your y value and putting it over your x value. So remember, in a table of information, the cost is always considered to be a y value. Here, in this problem, the number of adults is going to be our x value. So when we're setting this up, you can check any one of these. You should actually check all of them and make sure that they all come out to the same thing. So 75 over 1, 150 over 2, 225 over 3, doing 375 over 5, doing 750 over 10, and then doing 7,500 over 100. Okay, we're wanting to check every single one of these, and all of them come out to equaling the exact same thing. They all equal 75. Okay, so that means that K is equal to 75. If I were to write it as an equation, who remembers what the equation would be? Maria? Yeah? Yeah? Y equals 75x. Good. Okay, as an equation, it's just y equals whatever your k value is, whatever your constant is, times x. That's your equation. All right, number 15. A scale of a map is 1.5 inches equals 120 miles. On the map, two cities are 3 3/4 inches apart. So what is the distance, the actual distance between those two cities going to be? Set it up as a proportion. We've got the information that we know. We have 1 1/2 over 120, right? 1 1/2, this is inches. 120, this is miles. So when I'm setting up my other proportion, or the other side of my proportion, where am I going to put 3 3/4 inches? On the where? On the top. We're going to put 3 3/4 inches on the top because inches were on the top. I want to know how many miles are they apart. That's my x. And then you get to your cross product. So multiply and multiply. That's going to give us 1 1/2 x is equal to 450. Because 120 times 3 3/4 equals 450. Then all you have to do is divide. Just divide by 1 1/2 on both sides. And you'll get x is going to be 300. All right, problem 16. I want to know whether the tables are proportional or non-proportional. Remember, if they are proportional, then every one of the y over x values are going to be equal to each other. If they're not all equal to each other, then it's not proportional. So go ahead and do number 16 on your own. Identify if it's proportional or not proportional. All right, for my first table, is it proportional or non-proportional? Proportional, right? If we take each one of the y's, so these are my y's, my money, my time is my x, so I'm going to be doing this as 75 over 5. I'm going to do the next one as 90 over 6, and then the last one's going to be 120 over 8. When I do all of those, they all come out to equaling what? 15, right? 75 divided by 5 is 15. 90 divided by 6 is 15. 120 divided by 8 is 15. So they're all consistent. That makes this proportional. Okay, what about the second one? Proportional or non-proportional? Non-proportional, right? We're taking this, we're going to do 30 over 2. We're going to do 90 over 8. And we're going to do 150 over 14. Okay, when we work through all those, 30 over 2 comes out to 15, but 90 over 8 comes out to 11.25, and 150 over 14 comes out to like 10.7. Okay, so that is non-proportional because they're all different. All right, so taking a look at problem 17, we want to find, so I'm telling you that these are proportional relationships. Okay, this is a proportional table, this is a proportional table. I just want to find the constant of proportionality, and then I want to put it in an equation form. So all I'm doing is taking my y values and dividing them by my x values. So I am taking 1 and dividing it by 2, or taking 2 and dividing it by 4, or taking 3 and dividing it by 6, and I could do 4 divided by 8. Oops. I could do 5 divided by 10. All of these are going to be equal to each other. They are all equal to each other because they're all going to equal 1/2. Right? 1 over 2. 2 over 4 is 1/2. 3 over 6 is 1/2. 4 over 8, 1/2. 5 over 10, 1/2. So you can put 1/2 or you can put 0.5. It doesn't matter which one. And then as Maria had stated before, when we write it as an equation, it's y equals, and then whatever your number is, so 0.5 or 1/2, and then x. Okay? Let's take a look at the next one. Number of trees and the number of apples. The number of trees is our x. The number of apples is our y. So again, take your points of y and divide it by your points of x. I'm just going to choose one of them. I'm just going to do 78 over 6. If I do 78 over 6, it's going to simplify to 13. If I do 26 over 2, it's 13. 39 over 3, 13. So on and so forth. You're always going to get 13 here. So we know that our k value is 13. So then our equation is y equals 13x. Go ahead and flip it over to the last page. Did you still need that? Oh, I didn't know if you were writing still. Okay. All right, number 18. For number 18, we want to know what does the point 1, comma, 1.5 mean? 1 and 1.5. In case you can't read what these are saying right here, write this down. This is cost. So this is money. In case you can't read what that is, I know it's very tiny. And then at the bottom, this is liters. Liters of gas, gasoline. So we want to know, what does the point 1 and 1.5 represent? So remember, when we're looking at a graph, the very first value is our x value. The second number is our y value. So we're saying that this point that they've got located here, this is when x is equal to 1, and when y is equal to 1.5. So what this is representing, it's 1.5 what? Dollars for every 1 liter, right? $1.5 for every 1 liter. Okay, so we can write that down. It's $1.50 per 1 liter of gas. That's what that represents. Or they might write it in reverse. They might say 1 liter of gas is $1.50. Okay, they could reverse it and just say it's 1 liter of gas, it's $1.50. You just have to understand that the first number is going to represent your x value, so you've got to read what your graph is labeled at. You got to read those labels. That it is, I mean, this could be something else. If I said this was, 10 and 15, then that would mean it's 10 liters of gas and $15. Okay, you have to understand that the first number represents your x-axis. The second number always represents your y-axis. Okay, let's take a look at number 19. We're going to solve for the value of r. To solve for the value of r, all we have to do is cross product. So we're going to multiply 11 times r, which is 11r. Then we're going to multiply 3 times 5. 3 times 5 is 15. Now to solve, we would divide both sides by 11. Now, is 11 going to go into 15 nicely? No. You can leave it as a fraction, though. R is equal to 15 over 11. And that's it. 15 divided by 11 can be written as the fraction 15 over 11. And that's as simplified as it gets. Perfectly fine. All right, number 20. We want to identify the types of slope of each graph below. So when you see a graph, you read your graphs from left to right. Let me make sure you understand that. We read a graph from left to right. So starting on the left side, you find where your graph is, and then you read it down to the, moving to the right. So as we're moving to the right, are we staying the same? Are we going up? Are we going down? What's happening here? We're going down. As we're moving towards the right, we're also having to go down. So the fact that starting at our leftmost point and we're going downward, this is called a negative slope. When you start at your leftmost point and when you're following the line, it's moving you downward towards the right, then that's a negative slope. The opposite of that would be this one. Starting at our leftmost point, well, our leftmost point is down here. As I move towards the right, what happens? I'm moving up. So if I'm moving up from left to right, we call that a positive slope. Now these are the two that people get confused on the most. They get these mixed up, so be very careful about these two. And I'm going to show you a video before class is over that kind of helps you to understand slope a little bit more. But when you have a vertical line, if you've got a vertical drop, we call that undefined. We call it an undefined slope. And when you have a horizontal line, we call that zero slope. You need to know what the slopes look like in their graphed form for the test tomorrow. You will have 8 graphs, and you will have to categorize all 8 of them into their proper slope. So, oh, this one's a negative, this one's a positive, this one's a 0, this one's an undefined, this one's a 0 again, this one's another positive. You'll have to do that categorizing and matching and dragging. So you need to make sure you understand what they look like, because it's very, very simple. Should be the easiest 8 questions you answer, but you want to make sure you know your graphs.